Hi and welcome. It's Gene from Maverickstar Observatory. Guys, I put in the title for you, you're committed. As soon as you begin to watch this video, and later on I will give you an opportunity to, opt out again. That is your second chance in this video. You ask a good scientist any question, it's going to give you a reasonable answer depending on whatever his background is. I'm quite a confident scientist, with what I've studied and what I've known. I've got 49 years on this planet. I think I've got a good grasp of what's going on. And this is a little bit of a different video. Generally we are leading, I believe, the field in geomagnetics with our observatory, and keeping people informed of what's going on with regards to that. This is an opportunity to observe something very rare. The last excursion was 12,000 years ago. The last geomagnetic reversal was 780,000 years ago, and it is in our daily reality having effects. And from my knowledge anyhow, and my research, has been taking effect for 30 years, since the 1990s, when the acceleration of the magnetic poles really began. I wanted to say in a video or two ago about, when I was younger, the summers were really summers. They're not the same anymore. You're probably gonna touch on that feeling that I am trying to express to you right now. If you're around about the 50 age, you're going to know what I'm talking about. When we had our summer breaks at school, it was like a heat wave that lasted a continuous 6 months and no longer does. And no one talks about this anymore. But I remember at 1 o'clock in the morning, you could still be outside feeling the heat, just as much as what you could do in the daytime. It was a real summer that we experienced, and nothing like what we experience today. Around 8 years ago, I started to point out to, in particular, the British public about the sundogs that are in the setting sun on the horizon. This is something that is more common in the Arctic Circle, not at this latitude that we're at right now and we experience. So, it's a real shocker. Things are changing, and we don't. I really feel for the younger people, because they would never have experienced those summers like we did when we were younger. And we are slowly going back into a glacial period, regardless of whatever you think or like to know or would like to understand. The facts are facts. Scientific facts are facts. The thing is with science is we have to have something repeatable for it to be, authenticated, basically. If the experiment repeats itself, let's say a clear solution when added, just off the cuff, chlorine, turns the solution blue. If it does it at the same cc's, liquid measurements, if it does it at the same cc's, and turns it blue every time, then that is a fact. We can repeat that experiment time and time again. It will do the same thing. It will turn the clear solution blue. I've done experiments where, I've mixed ethylene glycol with some of the household products when I was studying at university, and chlorine, and it's turned the solution blue. You shake it, it goes blue. It's quite an amazing thing. But what we're looking at when things that change colour are just the reconstruction of the molecule. Yeah, that's pretty much all it is. You know, when molecules take a particular form, they reflect a particular type of the visible spectrum. But you're not here for this. You're here for what the title said. You'll be committed from watching this video. And I suppose we better get on with that. You know, I'm accused a lot of time of waffling on. I just want to say something. You know what? There are people that do a 3-minute video every day, and I really don't know what people get out of 3 minutes, because there's a lot of questions, and I'll try and cover a lot of the answers that you might have later on watching the video. And I've got to right now just diverge briefly. I know you're going to hate me for this, but it's a bit of a cliffhanger. We're going to get on to, you're going to be committed a little bit later on in this video, but I've got to just say this right now. CERN has been coming up a lot in the comment section on the videos, and they're saying, you know, with their super cooled magnets that, you know, circulate a 25-kilometre radius, could affect, is it possible that it could affect the Earth's magnetic fields? And the answer is simply no. Give me a second, let me show you something. I'll give you a good reason why. Hold on. So just because they were local, right, we got a compass and some neodymium magnets. We'll try and wrap this up really quick for those people that are concerned about CERN affecting the magnetic field. So this compass is influenced by 1 Tesla, which is a measurement of the Earth's magnetic field. It's measured at 1 Tesla in strength. These magnetic neodymium magnets are probably in the range of about 20, 30, 40, maybe even more Teslas. And the reason why they are able to, you know, interact with the compass when they get close enough. It's very difficult when you're holding the compass up this level, but if I just rotate it, maybe that will affect it, maybe it won't. Okay, maybe if I hold it like that. Okay, the point is this. Let's say this is CERN's magnetic circle, 25 miles radius. You know, the magnets may be in the 1,000 Teslas in strength, but they still, after 1 mile, have no ability to affect your compass, or even closer to that. And the reason why that is because we don't think, or it is not commonly shared, and it's not discussed in universities. I believe it should be addressed because it's all electromagnetic at the end of the day. What's not being discussed is that the Earth does have 1 Tesla strength in magnetism, and it seems to have a very low ampage. That's the way to explain it, I think. If you're familiar with electricity, you know that voltage and amps are 2 variables of the same thing. And just to give you, for instance, if you've got electric shock off an object that is measuring 30,000 volts at 1 milliamp, it's not going to kill you. But if we reverse it and you get a shock at 25 volts at 300 amps, it's going to kill you. It's going to stop your heart beating. And that's the same way the Earth works. So we've got a very low ampage with regards to this, the power of the Earth's magnetism. That's why the neodymium magnets, these are able to, you know, on an ordinary day when you're holding your compass and you bring it into the vicinity of those, alter the compass needle. That shows that we're overpowering the magnetic field of the Earth with the neodymium magnets that are obviously at a higher voltage, but you know their ampage is very low. I can't, if I put this compass on the windowsill about 3 meters away, I can't use this magnet, which is more capable or has more Teslas than the Earth's magnetic field, to influence that compass. I can't do it. So, you know, hopefully that explains why CERN can't overpower anything related to the Earth. It's just simply not got the ampage behind it. It's got the voltage, hasn't got the ampage. You can have 1,000 Tesla magnet, super cooled, in a ring, 25 miles circumference, 100 miles circumference. It's not going to have any effect on the Earth's general magnetic field. But that explains that, hopefully, for those people. What we're really interested in is what the title's all about. And you're going to be committed from this point on out. So this is the disclaimer. If you really don't want to know what the world you live in is really about, or whatever belief you have, religiously or not, then is the point in time to turn this video off. I will also say that, you know, I wouldn't recommend you share this video to anyone. So those people that generally share it, don't do it. Because what I'm about to explain, and I'm going to diverge one more time before I do, just so you know where you stand right here and now with where we are at the cutting edge of technology and understanding of our world, but also, you know, what is taking place around us. So you need to switch off now, because for some people this will be too much, and people generally don't like to have the duvets uncovered from them when they're fast asleep on the night. So, you know, if you're one of those people, you know, now's the time to switch off. You've been given your warning, and then we'll go ahead. Okay, so with relationship to the subject of CERN, one thing that did intrigue me, and I would dare say intrigue the people that work at CERN, it was one of the incidences that they had where there was accelerating particles, to my belief, faster than the speed of light. And they had not only the particle that was rotating around that 25-mile-an-hour ring, or 25-mile ring in circumference, but they also had another one spontaneously appear. That's really interesting, because that brings me back to an experiment that was done in the 1950s with 2 atomic clocks. And what it proved was when one was put on board a plane and travelled at several hours, around about 500, 600 miles an hour, the plane was cruising at, and then come back on the runway, the atomic clock was put next to the other atomic clock that was on the runway and never travelled at any speed. One was slightly advanced than the other. And that proved time travel. Now, I've spent a lot of time thinking about this. How would you ever travel into the future if we've proven already we can travel into the past? If we can alter time just by the momentum of speed, how could we ever travel into the future? Well, you know, the faster we approach the speed of light, you know, time slows down and then stops and then starts to go back the faster we go. How do we ever travel into the future from that point? It's a question. And the other question is that comes alongside this is, you know, this is the second time they've proved this is feasible. The fact that they discovered another particle in the accelerator as the other one was travelling faster than the speed of light also proves time travel in the fact that we can go back in time. Now, guys, this is pretty amazing when you think about it. Can you imagine going back in time with the knowledge you've got right now? How much you could affect the influence of the future. Can you imagine how you could change the strategies of wars that we've had in the past right now with that knowledge? But the problem is, it doesn't seem to be a returnable journey. That's the thing. We can't go back. But here's the other thing, okay? That's putting that aside. You know, with CERN, that Binsby's talked about CERN and its ability to influence the magnetic field on the Earth. You know, we put that on the side. It's a good discussion. They proved again time travel is possible. Why they would not invest in that and go, you know, invest heavily into that, because you could change the past and therefore change the future. Whether it's been done already is another matter, but I don't believe that after discovering that they wouldn't have just left it there alone. Okay, if that blew your mind, what I'm about to tell you right now will. There was another experiment done in the field of quantum mechanics, and it involved an experiment where electrons were being fired through a single slit and then a double slit, and they found out eventually, I'm going to cut to the chase, I'm not going to beat around the bush, they found out that when subatomic particles like electrons are being observed, they behave different. Through observation, they behave different. This is an experiment that's been repeated. The very same subatomic particles we're talking about, the ones that are present with you right now, they're the ones that are making up your anatomy right now. And when they're observed, they behave different. I ask you, is that not conscious? If you agree with me, I don't see how you can disagree with me on this, but are your thoughts private? Are your actions not observed? I've heard a lot of scientists trying to describe this in a lot of different ways to people, but because the idea is so far out of the box, it's very hard for ordinary people to comprehend that. The truth of the matter is that if we observe these particles, they're observing us. Simple as that. If they're observing us and they behave different because they're observation, then they're conscious. And that means every little bit of you is conscious. Every little bit of this world is conscious. Every bit of this universe is conscious. And it should come as no mistake that an equation like I have often showed people on this channel is by no coincidence. If such an equation existed, it proves the universe that we live in is conscious. It's amazing. It really is truly amazing world that we live in. And we are being observed. For whatever reason, we are. And just like if we was being observed, we probably would, if we all agreed, behave a little bit different. And sometimes it's nice to know that we're not, but it's not always the physical observation that we observe others looking at us. It's also the other. You have to take that into consideration after now knowing this. And if you don't take my word for it, look up quantum physics. Look up that basic experiment that was repeated time and time again. It's telling us something about the world in which we're living. To some, it is complete beauty and bliss. It is a warm blanket over us. It is like cruising at an altitude which is above all the turbulence. You know, it's beautiful. To others, you know, it's a little bit uncomfortable. We have to live with that fact. You're observing me. Everything around you is observing you. Let's hope that this conscious doesn't also include judgment. Guys, link down there if you want to help support what we do usually on this year's observatory, and I'll say what I usually do. Guys, take care of your loved ones, as always. Bye for now.